Today's lesson is going to be about triangle, but it's going to be about midpoint and altitude, angle bisector, perpendicular bisector, and perpendicular. And that's it. So let's work on it. So first, and the median and the midpoint, which, as I said in the first sentence on the video. Okay, so first for the midpoint. So the midpoint, so here's a basic idea of a midpoint. Let's say you have a triangle. The midpoint is the middle point right here, which split two triangles like this, and this side is congruent to this side. So we have a triangle ABC split, so you get D right here. That means AD is congruent to DC, Washington, DC. Okay, that's it for the midpoint. Very simple, very easy. Yeah, that's it for the midpoint. Midpoint is right here. So here's the midpoint is. Midpoint, so let's say if I have a triangle. The midpoint is basically the middle point. So this will be right here. So that's the midpoint. And split two, so midpoint is midpoint of one side. Split two up, so this side are congruent. Let's say we have a A, B, C, this point to D. That means AD. This is the same, so that's all congruent to DC. Washington, DC. You write CD if you want, don't really matter. But that's it for the basic idea of the midpoint. Now for the median. Median, this is the midpoint, but I just erase some word. Let's change it to here and here. So the median is basically a segment, start from the vertex down to the midpoint, which is right here. So start from the vertex, then down to the midpoint. So this right here, this line, this segment is the median. Yeah, and that's basically what is the median. And of course, it is this side congruent. This is the same idea as the midpoint. And also know that the BD, the segment is perpendicular to side AC. Segment AC, side AC. So BD, so segment BD is perpendicular to AC, like side AC. Okay, that's it for the median. Okay, now we're going to talk about the altitude. What is the altitude? The altitude is very simple, literally very simple. So let's start from the vertex. It's right here. It's kind of like a height, but it's not the height. So you draw down. The altitude, it's form right angle. So altitude, form right angle. So the altitude, that's the altitude right there. Just form a right angle. And okay, so let's write D. And also know that segment BD is perpendicular bisector of side AC or segment AC. That's it for the altitude. A form right triangle, and BD is perpendicular bisector of AC. Turn the light on, hold on. Okay. So let's say we have a segment AD. Let's say we have a line go across it. This line It's called a perpendicular bisector. But why though? Why is a perpendicular bisector? Well, a perpendicular bisector, the definition is, so this right here, that when it's intersect, can you tell what it is? Yes, you got it. It is the midpoint. So the midpoint, we start with M. So let's just say M. Because that's the midpoint. You know, this midpoint is split into two congruent sides. So, you know that AM is congruent to BM. MB is kind of, I don't know, but we're gonna write BM. Okay. And this kind of look like an altitude, right? If you draw it from here, but this is the altitude of a triangle. But you know, altitude is form right angle. So this form right angle, okay? So a perpendicular bisector is basically an altitude. Well, it's not a triangle, but it's an altitude and a midpoint. So form right triangle. I mean, it form right angle. Okay, that's how we know is perpendicular bisector. And now for the perpendicular bisector theorem, let's say we have any point on the graph. I mean on this line. Let's say point P. Let's do point K. Okay, we're gonna do point K. If you connect to the endpoint of this segment, which is A and B. So AK, okay, AK, I just came this. So AK is congruent to KB, BK. So these are congruent and form a triangle. And this line right here is congruent as well, using reflexive property because it share the same side. So you get the SS postulates. These two triangles are congruent. Very cool, right? So let's have a point down here. Let's say point X. So connect the point to the endpoint. These are congruent. We're gonna use probably 4 line for this. And this congruent to 5. So AX congruent to BX. And AM is congruent to BM. And MX, well, it's congruent to MX because it share the same side. That's it for perpendicular bisector theorem and why is perpendicular bisector. You know what I'm saying? Angle bisector. What's an angle bisector? Here's the definition, pop up the screen. This is my definition because angle bisector is kind of easy, but I'm gonna add a ChatGPT definition too. But here's the definition, pop up the screen. Right there. Do you see? I know it's a whiteboard, but when I edit it, it's gonna be a text right here. So I'm gonna draw this ray right here. So this ray, split it. So this small angle right here is congruent to this angle. So if split in half, 60 divided by 2 is 30. So this angle is 30, this angle is 30 as well. Because if they add up, equals 60. And this green line right here, that is the angle bisector. Very simple, right?